This is Martin Carlisle with spyfi from pico2018 2018. James Brom, James Bond's less franchised cousin, has left a secure communication with HQ running, but we couldn't find a way to steal his agent identification code. Can you? Connect on port 34490. All right, so if we look at 34490, it's going to ask me for a situation report, and then it's going to give me back a bunch of, looks like hexadecimal numbers. All right, so let's take a look at the source code, which I've downloaded here. And the key was it asked me about the mode. And the mode here is electronic codebook mode for AES. Now, what's unique about electronic codebook mode for AES is the same input always encrypts to the same output given the same key. Okay, so there's some key. Presumably we don't have the real key here in the source code. We don't have the real flag here, but what it's going to do is it's going to take this message where it fills in the situation report and the flag into this message and encrypt it and give me the encrypted value. It's also padding that out to a length of 16. So this AES is 128-bit AES, so 16 bytes, 128 bits. So every 16 characters will be encoded as a block, and then the output of that is being put in hex. So every 2 hex digits corresponds to 1 character of the output encrypted. All right, so if we look at that, what we're going to want to do is try to line up something we know with this flag. And I've written a couple Python programs here that will hopefully illuminate this. So here we have this solve spy.py. And what I've done here is I have connected. I read until the situation report. Then I'm going to send 42 X's followed by if code is P, followed by 32 Y's. And so the point of that is that I'm going to try to line up something I know, which is the identifying code is whatever, with that. And so if we were to count this out, if I put those 74 plus if code is 16 characters there, that's going to cause the blocks, when I look at 16 characters at a time, to line up. So I'll run this program. And the key thing to note here is that I have a couple blocks which are identical. Now I have these 2 blocks which are identical. These 2 blocks are identical because I have those 42 Y's, so those are all together, or 32 Y's rather. Then I also have just before that this block which matches with this block. So this block is my if code is P, and that's going to be exactly the same as if code is and the first letter of the flag, and I'm going to assume that the flag begins with pico-CTF, so I have that P there, and you'll see that that match. So the first character of my flag is a P. So I can just verify by looking at those encrypted blocks. So now I'm going to create a slightly longer program, and what it's going to do here is I'm going to take away one of those characters, and I'm going to now try to check every letter in the alphabet to see what the next thing is. And I'm going to see if I can get these blocks to match again, and I'll try that for each letter in the alphabet. So it connects up, and we'll see a success there with the letter I, which is what we expect with the flag to begin with pico-CTF. And so again, by trying different letters, we now get where we put if code is PI in the situation report, and that encrypts the same value as this if code is PI here with the flag, which means that I've gotten that second character of the flag correct. So now I have a third program here, and I'm going to say, okay, well, I know so far that I have a P. And I'm going to loop through up to 32 characters. I'm going to check all of these different uppercase, lowercase, numbers, symbols. And each time I find something that matches, I add it to known so far. And I keep track of how much of the flag I know so far. I do fewer X's and fewer Y's, adding more each time to the known so far. Each time I find a match, I print success. And I've been having a problem with the server not letting me connect incredibly often, so I added a little sleep here so it only connects 1/100th of a second. So, and you can see there, this is what happens. It crashes when I'm connecting too fast. I also get all those messages from the Pwn Tools library. So I'm going to just grep for this success. You'll see it's working through building up the string one letter at a time. So at each point in time, I've lined up some number of letters here that I know, and I just have one letter here that I don't know. And I'm looking for this encrypted block to match this encrypted block. So agent is the coolest. 463. And that finished. So it turns out the flag is more than 32 characters long. So I've written a fourth program. So in this fourth program, all I did was add another 16 to the Y's so that this thing would have enough Y's to delete. And I've moved this encrypted block slightly further down. So here I've got the agent is the coolest, 463, so that's what I know so far. It's going to find the rest of that flag. And there you go. So I've got my whole flag. So again, in summary, the key thing about electronic codebook mode is that the same input always corresponds to the same output. And so if you have the ability to encrypt data of your own choice, which I do here with the situation report, I can get it to give me one character at a time of the flag by comparing the encrypted value of the string that I control with the encrypted value of the flag with stuff I know with just one character and seeing which of the characters matches. I simply repeat that for every character in the flag, and I've gotten the entire flag.